Why did a $1 billion luxury mega-project designed to be the best car in the world become one of the most expensive financial disasters in automotive history? Today, we are analyzing the Volkswagen Phaeton and the hubris of Ferdinand Piëch to see exactly where the math, the branding, and the engineering went wrong. By the end of this breakdown, you will understand the badge paradox, a psychological barrier that $1 billion in engineering couldn't break, and the specific reason why this car's air conditioning system alone cost more than most luxury sedans. Most people think the Phaeton was a bad car. They're wrong. It was arguably the best engineered vehicle of its era. It didn't fail because of the mechanics, it failed because of the physics of human perception and a catastrophic management ego that ignored the fundamental identity of the brand. If you are fascinated by the hidden flaws in massive infrastructure and the forensic autopsy of high-stakes technology, you are in the right place. Subscribe, because every collapsed legacy leaves a blueprint, and we're here to decode it. I've always been fascinated by how a single microscopic miscalculation in market positioning can bring down a mountain of world-class engineering. Once you understand the rigid parameters set for this project, the $1 billion disaster starts to make total sense. To understand the collapse, we have to look at the engineering fundamentals of the Phaeton's creator, Ferdinand Piëch. Piëch was not just a CEO, he was a brilliant engineer and the grandson of Ferdinand Porsche. He didn't just want to build a car, he wanted to build a monument to his own technical superiority. From a physics standpoint, he wanted to create a vehicle that defied the traditional limits of comfort and speed. But the math of the Phaeton was anchored in 10 impossible mandates that pushed the boundaries of automotive science. Imagine a car designed to be driven at 300 kilometers per hour all day long in 50-degree heat while maintaining an internal temperature of exactly 22 degrees Celsius. Let's look at the actual blueprints of this requirement. Most luxury cars of the early 2000s would struggle with the thermal load of such a feat, but Piëch insisted that the Phaeton must be able to achieve this while also remaining perfectly still. Watch what happens to the internal structural integrity of a budget when you have to over-engineer every single component to meet a standard that no customer actually asked for. To solve the air conditioning challenge, engineers had to develop a draft-free system where the vents were hidden behind wood panels, only opening when the cabin needed a sudden burst of cooling. This was a masterclass in cinematic forensic realism, an engineering marvel that cost a fortune and added hundreds of pounds of weight to the chassis. According to the structural reports of the Phaeton's development, the car was built on the D1 platform, which it eventually shared with the Bentley Continental GT and the Flying Spur. This is where the hubris becomes clear. Piëch was essentially building a Bentley and putting a Volkswagen badge on the front. He ordered the construction of a brand new $200 million glass factory in Dresden specifically to assemble the Phaeton. This wasn't a factory, it was a temple of engineering. It featured Canadian maple floors, no robots, and workers wearing white lab coats. It was an infrastructure project built on the assumption that if you build the most perfect facility, the world will forget that Volkswagen literally translates to the people's car. The engineers were anchoring the foundation of the brand into the porous limestone of luxury status. Here's what most people get wrong about this disaster. Men over 30 who value analytical truth should look at the torsional rigidity variable. The myth is that the Phaeton was just a heavy Passat. The reality is that the Phaeton's chassis was the most rigid in the world at the time. Piëch demanded 37,000 Newton-meters per degree of twist. This is a number usually reserved for high-performance race cars or armored vehicles. But because the car was so heavy and so overbuilt, it required massive V12 engines and complex air suspension systems just to move. This created a massive retention spike in maintenance costs. Most people don't realize the physics at play here. The more you over-engineer a vehicle to be silent and vibration-free, the more weight you add, and the more stress you put on every other component. Let's look at the actual blueprints of the market failure. In the luxury segment, customers aren't just buying steel and leather, they're buying social signaling. A Mercedes S-Class or a BMW 7 Series carries a specific psychological weight. When Volkswagen tried to enter this space, they hit the complexity ceiling. A customer willing to spend $100,000 on a car did not want to take that car to the same service center where a $20,000 Golf was being repaired. The autopsy of the disaster showed that despite the Phaeton being technically superior to its rivals, it lacked the structural brand equity to survive. The math of the luxury car market is 90% psychology and 10% physics. Piëch reversed those numbers, and the project collapsed as a result. But here is the most terrifying detail the accountants realized too late. Volkswagen was losing roughly $30,000 on every single Phaeton they sold. It was a $1 billion sinkhole. To keep the project alive, Piëch used his immense power within the company to ignore the geological reports of the sales data. He was obsessed with the autopsy of excellence, the idea that no cost was too high to prove a point. The result was a vehicle so complex that even simple repairs became a nightmare. For example, to change the battery on certain models, you had to navigate through layers of trunk lining and electronic modules that required specialized factory tools. This is where the engineering reasoning turns into a liability. Most people don't realize the physics of brand dissonance. If you look at the landscape of modern infrastructure and corporate strategy, you see the same mistake being made. Companies trying to move upmarket without understanding the foundation of their own identity. The reason the Phaeton disaster matters today is that it serves as the ultimate warning against engineering for the sake of engineering. If you build a bridge that can withstand a nuclear blast, but it's located in a place where no one needs to cross, you haven't built a bridge, you've built a monument to waste. The hubris of the Phaeton was the belief that a technical spec sheet could override a century of brand history. The real-world application of this failure can be seen in the current EV transition. Many legacy automakers are trying to build ultra-expensive, high-tech electric cars to compete with Tesla, often making the exact same Phaeton mistakes. They are overcomplicating the software and the hardware, leading to massive recalls and financial losses. The autopsy of the disaster at Volkswagen reveals that the company eventually had to pivot. The Phaeton was quietly discontinued in most markets, and the glass factory was repurposed to build electric Golfs. The billion-dollar mistake was finally laid to rest, but the lessons remain in the blueprints of every luxury car built since. So the reason this $1 billion project collapsed comes down to three things: a total misalignment between the engineering goals and the brand's identity, a catastrophic management ego that prioritized technical mandates over market reality, and a financial model that ignored the staggering costs of over-engineering. Ferdinand Piëch got exactly what he wanted, the best car in the world, but he lost what the company needed, a profitable product. The Phaeton remains a ghost car on the used market, a masterpiece of engineering that you can buy today for pennies on the dollar, provided you're willing to face the terrifying math of its repair bills. As we look at the summary, the takeaway is clear. In the world of massive infrastructure and mega projects, the human variable is just as important as the physics of the materials. If the people don't believe in the vision, the structure will not stand. The Phaeton was a bridge to nowhere, built with the finest materials and the most advanced techniques, but it lacked the most important structural support of all, a reason to exist. Every collapsed legacy leaves a blueprint, and the Phaeton's blueprint is a warning that excellence without empathy for the market is just an expensive form of arrogance. If you learned something new from this investigation into the forensic reality of the automotive industry, subscribe. Next, we're breaking down why the $20 billion Big Dig in Boston became the most expensive and flawed highway project in American history, and the epoxy failure that led to a catastrophic ceiling collapse might surprise you. From a physics standpoint, a tunnel is a constant battle against the weight of the Earth, and we're going to look at exactly where the math falls apart. Every disaster has a reason, and we're here to decode it. Next time you see a car on the road, look past the paint and the leather. Look at the engineering and the ego that brought it to life. I'll see you in the next investigation.